All right. What is the definition of what's called a normal distribution? So we already know that a distribution is generally the shape of the data. So if you were to take the data and create a dot plot of the data, and let's say it looked something like this, then you would say that you could draw kind of like a line over the top of it, trying to conform to the shape of the dot plot itself. And this line that we drew, we would say that this is the shape of the distribution. So the distribution is a little bit of a visual description of the form that the data itself takes. So what do we mean when we talk about a distribution, and specifically, what is a normal distribution? Well, a normal distribution is a distribution that is symmetrical and bell-shaped. So a normal distribution is defined by two parameters, the mean and the standard deviation. So if we're looking at a normal distribution of a sample, then we'll be looking at the sample mean and the sample standard deviation. If we were looking at a normal distribution of data that represents a population, then the normal distribution will be working with the population mean and the population standard deviation. Now, before I kind of talk about this equation, let me just move down a little bit more and show you what the picture of a normal distribution looks like. So you can see that a normal distribution, which I said earlier, is symmetrical and bell-shaped. And so you can see here this curve right here that starts low on the edges, kind of rises to a maximum, comes down the other side, and kind of flattens out on the opposite side. Now, this is what we refer to as it being bell-shaped or shaped like a bell. Now, it's symmetrical because it has a line of symmetry right down the middle. And what that means is everything on the left-hand side is mirrored on the right-hand side. So, if you think of, your face, you've got two eyes, a nose, and a mouth, and ears, right? The human face has a line of symmetry right down the middle, where it's the same on one side as it is on the other. So this is what it means for it to be symmetrical. And so you can see that the shape of the normal distribution is symmetrical and bell-shaped. Now, this line that is the normal distribution shape, okay, that I'm kind of drawing here in green, there is a mathematical equation that defines that shape. And that's what this equation is here. Now, we're not going to be using this equation directly, but it's important to know that every point on this line, on this normal distribution, can be calculated using this equation. So how do you do that? How is that done? Well, notice that when we look at this equation, that equation relates to components in the normal distribution graph. So for example, here we've got mu. And mu is the center of the normal distribution. Mu is actually on the line of symmetry for the normal distribution. And in the previous chapters, we would calculate the standard deviation and the mean. And I showed in previous examples how we can calculate how many standard deviations away a certain value is from the mean. So we can go 1, 2, or 3 standard deviations above the mean, and we can go 1, 2, and 3 standard deviations below the mean. And you'll notice that standard deviation is here and here in this equation. So the only thing that's required is you need to input some x value. So this will be your input. So if you put in some value of x, so let's say this was some value of x here, then if we put a value of x into our equation, it will spit out a resulting value of y, or a function of x. So this would be your output. Now, your calculator is going to be using this equation for you, but I think it's important to kind of know what your calculator is doing. Now, there is a shorthand for the normal distribution, and it's this here. So this shorthand, what it means is that we've got a random variable x. This capital N means we're dealing with a normal distribution that has a mean and a standard deviation of a certain number. So you might see this used in practice, or you might see this on a homework problem. So what this means is that for a random variable, the data is normally distributed with a mean, with a mean of 5 and a standard deviation of 2. So if you ever need to know what the mean or standard deviation is, it's kind of given in the shorthand for a normal distribution. So let me see. Let's read what's down below here. It says the normal distribution is centered at the mean. Okay, that's what I just talked about here. It is symmetrical about the mean. So here's the mean. It's the same on this side as it is on that side. And the width of or spread of the graph is described by the standard deviation. So the width of the graph is defined by 1, 2, and 3 standard deviations away from the mean. Okay, so it turns out that this normal distribution is very commonly found in nature, in psychology, engineering, medicine, and economics. All right, so let's go ahead and stop there with this definition of distribution. All right, let me know if you have any questions.